Welcome. Today we discuss part 2 of the chapter Binomial Theorem for preparation of joint entrance main, advanced and for different state level joint entrance examination. First problem is problem number 3 of that chapter, and the problem is the greatest number by which 101 to the power 100 minus 1 is divisible by options 10 square, 10 cube, 10 to the power 4 and 10 to the power 6. Very simple problem. A number is given 101 to the power 100, a big number. This minus 1, we have to find the greatest number by which this is divisible among that. So this can be written as this one plus 100, 101, this to the power 100 minus 1. Now expand it binomially. This is equal to 1 plus NC1 means 100C1 into 1 into 100 plus 100C2 into plus so on, and these terms will contain higher power of 100 square. It is equal to minus 1, sorry, minus 1 is there. So this minus 1 and that minus 1 cancels. So it is equal to 100 into 100. 100C1 is 100 into that plus 100C2 is 100 into 99 by 2 into 100 square plus so on. Now you see this is 10 to the power 4, 10 square plus this is at 100 cube. This is more than 100 square into 50 into 99. So of order 110 to the power 4. So clearly this thing is divisible by that. So option C is correct. Next. Now question number 4. A and B are coefficient of x to the power n in 1 plus x to the power 2n and 1 plus x to the power 2n minus 1. Then A by B is equal to options 9, 8, 4 and 2. This is one binomial, another binomial, and A is the coefficient of x to the power n in that, and B is the coefficient of x to the power n in that case a by b how much? Last day we have seen that 1 plus x to the power n, when it is expanded, it is 1 plus nc1 into x plus nc2 into x square plus nc3 into x cube and so on. Clearly from there, coefficient of x to the power 1 is nc1, coefficient of x square is nc2, x square nc2, x cube, that of x cube, is nc3. So a is coefficient of x to the power n in that, so it is equal to 2n cn, and b, which is coefficient of x to the power n in that, here n is changed, it is actually equal to 2n minus 1 cn. So now we clearly get a by b is equal to 2n cn by 2n minus 1 cn is equal to factorial 2n by factorial of n into factorial of their difference. 2n minus n is n, divided by that it is factorial of 2n minus 1 divided by, which will be to be put there, factorial n into factorial of their difference, that is n minus 1. Now things become extremely simple. This cancels with that, this cancels with that, leaving a factor n, this cancels with that, leaving a factor 2n there, because 2n into factorial 2n minus 1 is factorial 2n. So it is 2n by n, so answer is 2. So option D is correct. Number 5. In expansion of a minus 2b to the power n, the sum of T5 and T6 is 0. Then a by b how much? A by b options: 2 into n minus 4 by 5 by 3, 2 into n minus 4 by 5, n minus 4 by 6, and last option 4 into n minus 4 by 5. Here one binomial is given, a minus 2b to the power n, a minus 2b to the power n binomial, and given that its fifth term plus sixth term is equal to 0, it is 0. Then to calculate a by b, now for this expansion T5 is T5 is equal to NC4, just one less than that. First term to the power n minus 4 into second term here is minus 2b 2 to the power 4. Similarly, T6, sixth term is equal to NC5, one less than that. This is one less than that. A to the power n minus 5 difference into second term is minus 2b to the power 5. So from our given condition T5 plus T6 is equal to 0, we must have NC4 a to the power n minus 4, and actually you see this is positive, minus to the power 4, so 2 to the power 4 b to the power 4 plus this one. This is actually for that factor it is negative, so minus NC5 a to the power n minus 5 into 2 to the power 5 into b to the power 5 is equal to 0. So between this and that we can take a to the power NC4 a to the power n minus 4 2 to the power 4 into b to the power 4 is equal to NC5 a to the power n minus 5 2 to the power 5 into b to the power 5. From there 2 to the power 4 and 2 to the power 5, 2 to the power 4 will be cancelled, leaving here 2. A to the power n minus 4 and a to the power n minus 5, a to the power n minus 5 will cancel and only a will be left. And from this and that, only b will left there. So we get NC4 into a is equal to NC5, this cancels into 2 into b, so that a by b is equal to this a by that b is equal to NC5 by NC4, NC5 by NC4, and 2 is left there into 2 is equal to factorial n by factorial 5 into factorial n minus 5 into factorial n factorial 4 into factorial of n minus 4 into 2. Now this cancels. Between this and that, 5 is there. Between this and that. Between this and that, n minus 4 is in numerator only, because it is n minus 4 into a factorial n minus 5, one less than that, into 2. So answer is 2 into n minus 4 by 5. 2 into n minus 4 by 5. So option B is correct. Next problem. Problem number 6 of that chapter. sixth problem is sum of last 30 coefficient 30 of 1 plus x to the power 59 when expanded in ascending power of x is 2 to the power 59, 2 to the power 58, 2 to the power 30, 2 to the power 29. One binomial is this, and we have to calculate the sum of last 30 coefficients of that expansion. Option is there. So we know that this contains 59 plus 1, that is 60 terms. So last 30 coefficient is half of the coefficient, half of total coefficient. But we know that first 30 coefficient and sum of last 30 coefficients, they are same. And total sum is equal to 2 to the power 59. So last 30 coefficient is equal to half into 2 to the power 59. So that it is equal to 2 to the power 58. So this is correct option. So once again, I am discussing the problem. It has 60 terms, and we know that sum of first 30 coefficients is equal to sum of last 30 coefficients. And total sum is 2 to the power 59. So our answer is sum of last 30 coefficients of that is equal to half of total sum, means 2 to the power 59. So answer is this. Next. Problem number 7 now. 7. If 1 minus x plus x square to the power n is equal to a0 plus a1x plus a2x square plus a3x cube up to a2n x to the power 2n, then value of a0 plus a2 plus a4 up to a2n is how much? Options: 3 to the power n plus half, 3 to the power n minus half, 3 to the power n minus 1 by 2, and 3 to the power n plus 1 by 2. These are the options. Actually, this is not binomial because 3 terms are there, trinomial. But given that this when expanded in ascending power of x, it is equal to that. Expansion is given. So in that case, we have to find the value of even coefficients, a0, a2, a4, their sum. We can write a0 plus, this is 0, a1x plus a2x square plus a3 x cube plus a4 x to the power 4 up to a2n x to the power 2n is equal to 1 minus x plus x square to the power n. Its last term will contain x to the power 2 x square to the power n, that is x to the power 2n, that is there. So it is a formula. Given that it is a formula, so when we put x is equal to 1 on both sides, then this must be equal to that. When we put a particular value of x on this and same value in that, result will be same. So putting x is equal to 1 on both sides. So it is equal to a0 plus a1 plus a2 into 1 plus a3 up to a2n is equal to 1 minus 1 plus 1, that is altogether 1 to the power n is 1. Now put x is equal to minus 1 on both sides. So it is equal to a0 minus a1, it will be plus a2 minus a3 plus a4, last term will be minus to the power 2n, that is positive, so a2n is equal to how much? 1 minus plus 1, it is 1 minus into minus 1, so 1 1 1, 3 to the power n. Now add these two, it is 2 times a1 a0, this and that, this cancels, plus a2, a3 will be cancelled, plus a4, that is all even coefficients, up to a2n is equal to this plus that, that is 3 to the power n plus 1. So even sum of even coefficients is equal to this divided by 2. So this option is correct. Next. Now problem number 8 now. If C0, C1, C2, Cn are coefficients in the expansion of 1 plus x to the power n, then the value of C1 plus 2C2 plus 3C3 up to NCN, how much? Options: n into 2 to the power n minus 1, n plus 1 into 2 to the power n minus 1, n plus 1 2 to the power n, and n plus 2 2 to the power n minus 1. Given that, in that problem, given that the C0, C1, C2 up to Cn is, these are the coefficients of this binomial expansion. That means we are given C0 x plus C1 x plus C2 x square plus C3 x cube up to Cn x to the power n is equal to the total expansion. Here C0 means NC0. C1 means, that is CR means NCR. So these are given. We have to calculate the value of that expression. So differentiating both sides with respect to x, we get this is absolute constant, so its derivative is 0. So C1 into 1 plus C2 into x square, derivative of that is 2 into C2x plus 3 into C3 x square up to n Cn x to the power n minus 1 is equal to n into 1 plus x to the power n minus 1. Simple differentiation. Now it is a formula. After differentiating both sides, this is also a formula. So we can put some particular value of x in left hand side and right hand side, it will be equal. Now to get result, put x is equal to 1 on both sides. So it is C1 plus 2C2 into 1 plus 3C3 into 1 square 1 up to n Cn, it is equal to n into 2, 1 plus 1, 2 to the power n minus 1. So I get the required result. C1 plus 2C2 plus 3C3 is equal to that. And answer is n 2 to the power n minus 1. So first option is correct. Here, for all type of problems, or all problems of that type is what? The coefficients C0, C1, C2, C3 are coefficients, and with it some integers are associated with regular interval. It is 1, it is 2, one more than that, it is 3, one more than that. In that case, in all type of cases, by differentiating, we get result. Okay, today is up to this. I request you, if you feel that it helps you, then you please like it, share it, and subscribe my channel. Okay, thank you.